Alright, welcome back generals to another Let's Fix Generals 0 Hour to make the best game ever. Last video we have been progressing our source lines association with the assembler lines, and we tested, but we found problem. So I do wonder if there is some sort of address collision, that there are things that are assigned the same address, but they're still different things. Like, to me, it's weird that we now have a thing that has this global name, this undecorated name, and then this decorated name, which does not match this at all. Like, this doesn't look like the same thing. So something is up with this thing. Maybe this is some item that we need to skip if we detect it as something that we can skip. But I don't know what it is. Let me ask here in the chat. Maybe Thompsons know this. So we have our watch function info. From PDB, I get some strange records. For example, somehow this $E3 function sits on this E3 function refers to Unicode string. We were looking at ASCII string. Hold on. Unicode string. Okay. Why is there a Unicode string function in ASCII string? Okay. Okay, so the compilant we are in now. Compilant info. So it's ASCII string.cpp. I don't understand. I don't understand. Why? This is strange. Address. I wonder. I wonder if there are so the decorated name is this here, right? I wonder I wonder if there are multiple of these strings. So function info dot decorated name equals that. Let's see. So function decorated name. That. Yeah. So if this would hit more than once now, then I think that would be interesting, right? On the same code path. What happened here? Oh. So if this hits twice, then maybe there's a lead. If this just hits once, so here we got one with E7. Twice. Okay, so it hit twice. And another time. And another time. And here's the correct one. Oh. Oh. Ha. Okay, but this is already relieving. So there is a correct one. This is a real deal. But these E7, E3, whatever, I don't understand. What are these things? Well, it's good. So this is a first hit, which is E7. Okay, so the question is there some property that these E3, E7 symbols have that disqualify them? Maybe. It is syntax function, these things. And they also have debug start and debug end. I don't get it. Okay, my suspicion now is that this here is returning us a children on a range. So if we give it an address and that falls within a certain range, then it finds us a symbol that may be unrelated strictly. Public function. How about here, when we get a symbol, we first check that this symbol, that the virtual address actually matches our search address. Let's see, maybe this will be of success. Let's see. So we have this child VA. Why is this called DW? It's a U long. Who cares? So we pass this here. By the way, I just realized we are shadowing the other symbol. Let's rename this to child symbol. So we get this. If get virtual address, let's say if it's not okay, then continue, and if child VA does not match this VA, also continue. Okay, let's try this. Maybe this works, maybe not. Okay, so this succeeds and this matches. Yeah, okay. Let's find this one here. Well, let's put a breakpoint here. Oof. Here. Ah. E11. Aha, look at this. So now I think this is gold. Yeah. So this find children, it finds us something that may not be necessarily be the thing we are looking for. So it finds us something, but is maybe not it. Okay. So here, continue. Okay, let's see if we get it for E3 as well. 11, E10, 17, 14, 16, 22. Yeah, a lot of all the E's here. Okay, that's good. Let's open our watch here. 32. E7, that is. E7, E3. Thank God. Okay, good. I appreciate this. I appreciate that. Okay, so this seems to be the fix. Yeah. Okay, but it makes sense now. Then let's put a comment. Skip child symbols that do not strictly match. Skip child symbols that do not strictly, well, find children X by VA may return symbols in proximity of search address. May return unrelated symbols in proximity of search address. Therefore, skip child symbols with addresses that do not match the search address. Okay. On that note, I think we also have other things where we search for find children, right? Let me see. Here, find children, read publics. Read publics. Okay. Find children. Find children. Let's search for by VA if there's some other. Find lines by VA. Okay, so there's only these two things. So I wonder if here here we should okay, where do we find this? Everything is commented out. Here. Here. No. Yeah. Okay, there's no. Yeah. Okay, then yeah, I guess that's all we do then. Good. I'm happy we found a solution. Okay. Okay, then let's get back to what we actually wanted to test, and that is, oh, we need to remove the debug here. So that, and this, yeah. Okay. Good. So that basically means there will be some symbols without public symbols, mangled symbols. Yeah, that's fine. Yeah, good. Then let's compile again. And let's run this. Okay. So I wonder how many matches do we have now? 5B, which is still 91. Yeah, okay. Good. Then let's see. Good. Let's put a breakpoint down here. Set source file. Okay, so basically we want to see if this now hits again or if we solved the problem. Let's see. Oh, it ran through without errors. Okay, I think this means that this is now successful. Yeah. Otherwise it would have hit one of these things. Okay, let's anyway, let's put a breakpoint in here and just look through some samples. Let's remove it here. Let's skip a little bit forward and let's look through some samples. So here we got 21 instructions, source lines, yeah. Line number 38, yeah. Okay, then let me let me what did we touch? PDB reader. Here. This. Turns out that this function returns symbols in proximity of the search. So now I double check that the returned symbol matches the exact search symbol and only proceed then. This now filters out all $e functions. Yeah. Good. Okay, so it passes all our asserts. So we can be confident that the result, that the lines perfectly match the assembler instructions. There's no errors. Yeah. At least for the 91 functions that we have. Maybe if we add thousands more, maybe there will be a case where it's wrong. We will see. Good. Then next. So we got now the line mapping and the instruction bytes mapping. That is done. It's now part of our ASM instruction. So that's good. So we can now work with this. This means we can now proceed to actually print this stuff in our ASM printer. And then it will be pretty much done. How about we have one quick look through to see if there's any dirt left that we should fix. So we made this smaller. This is good. That's actually quite a big change. Sizable array is a bit strange name. Sizable. Maybe we should name it sizable. Maybe we call it sized array. Sized array. Okay, let's do that. Sized array. Okay, stop debugging. Good. I will be right back. Okay, we are back. Good. All right. Then sized array. Yeah, I think sized array is a better name. Yeah. Good. Then let's get to the ASM printer. Let's see if we can make it work. So we know that we have max 11 bytes, right? Max 11 bytes. So FF, that is 4, 8, 12, 11. 11 bytes. Yeah, 11 bytes is max. So how many symbols would that be? 33, 34. 34. Okay, let's put here Oh, we don't care about this other one. Okay, just this. Okay, so address len. Let's do const express size t bytes len. So that is 34. It's quite a lot actually. 34, yeah. Bytes len, and then also put a const express size t so CPP line number len line number len. So we settled on, let's do put 6 because our max is 65,000 roundabouts. And then we do const express size t cpp line len equals, yeah, let's also do 80 here for starters. Maybe we call this number no line no len cpp line len compare len. So we have ASM len. Maybe we just call it CPP len. CPP line let's call it code len. Line len, code len. Yeah. Bytes len. Okay. Oof. Now this will actually make the whole thing a lot more complicated. Pad sideline. It only gets longer and longer here, the more stuff we add. So it will be pad white. Yeah. Okay, so I think what we need is pad ASM sideline. Pad ASM line. So the way I imagine this to look is that we have we have line number, yeah. Then we have the CPP, C++ code, yeah. Then we have bytes. Then we have the assembler instruction. Then we have here the comparison thingy. So this is one side, and then the other side will be ASM, bytes, and well, it won't have C++ code on one side, right? So this would be game that side, and this would be the Thyme.executable, Thyme.exe. Now the question is though, if we have if we have it inverted, like let's say the PDB is on the other side. So here is a game that, and here is Thyme. Then we would have C++ code here and the line here. No. Should be like this. To me, this indicates we should change the way this thing is built. Because if we build it like this and then add this and then this and this and this, it's complicated because we cannot just run through one. We cannot just iterate through one vector of something. So here it's running through all the comparison records, right? So it would not be possible here. We probably need to build first a vector for one line. We build a vector of strings. A vector of strings. Yeah, we build a vector of strings. And we append we go through the vector from top to bottom, and we first append the lines. And then the code. And then that. Yeah. It makes it a bit easier to process it, maybe. It gives us more freedom to process it. Basically, it allows us, like, let's say this is now the stuff, right? So it may, like, if we have it organized in a vector of strings, then it allows us to, like, process just these things here at the start, just the lines, or I can't select here. Let's create a new document here. So if we have it like this, it allows us to either just process these things, right, in one go, or it allows us to process this here in one go, right, this, right? But we are not limited to, like, processing the whole thing and then processing this thing. And it makes it easier because then we can, like, make this one processing, and then run the same processing here for this one, because it's the same thing, and we just append it. And the same here. This is one chunk of work, and then here for the other side is the same chunk of work, but essentially it does the same thing. Yeah. So it will be 3 tasks. It will be this here, then it will be the bytes, this, then this here, like we already have it, and then again this bytes, and then again this here at the end. Yeah. Okay, this is how we do it. Yeah. Okay, I realize now as well that we need something else. We need to build we don't have it yet. We need to build we need to load the actual C++ code first, also in a vector. Yeah. How do we do that? Let me see. ASM print. The question is, where do we want to do it? I mean, the printer should not really be responsible for loading C++ files to get the text, right? Some comparison result. What is in here? So there is function pair. Some comparison result. Okay, so append to string. So this is only for one comparison, output comparison results. Results. Bundle. Okay, we first need to figure out how we want to load the source code lines. So in our result bundle, what is in there? There is a compilant or source file name. The source file name. Compilant or source file. So essentially, to the ASM printer, we need to pass a string buffer. No, we need to pass it a std vector of all lines. Yeah. Okay, so we need we need to first read the CPP file or header and dump it into a vector of strings. And then, okay, let's not worry about what happens afterwards, just how we get this. So when we have comparison results in our bundle, we will have multiple function pairs in there that have the same that access the same Okay, so certainly we should load files just once. It within this body. A file is just loaded once because the bundle will refer to multiple places in there, right? Because there are multiple functions. So we load the file just once and then we use it for all sorts of function matches. Good. But there are also other bundles, like the next bundle, for example, which could also reference the file. And if you poach it here at the end of the iteration, it's lost, and then it would have to be reloaded again in the next. So there could be duplicate work if we do it this way. But on the other hand, if we keep all the files that we have loaded as we iterate, then the pile just keeps on growing, and we will have all the header and CPP files in memory. I don't know if that's desirable. can check how often it happens. Okay, so this bundle basically has here the comparison results inside. Yeah. Comparison results. And then there's a function pair. Yeah. Okay, so for starters, let's just create a structure. So it needs to be CPP file CPP file content. And that would std string, std vector of strings, right? Lines. Okay. And then we need a struct cpp file pair. std array. There we put the contents to pair. Right, so this is for left and right. And then using std array. No. Hold on. Hmm. Mm-hmm. Yeah. I think here it makes sense to use a map. So you do a CPP file pair map, and that will be a normal STD map for stable references. CPP file pair. What are we missing? STD string. CPP source. Yeah. I hope that makes sense. Okay, so I think we need to put these two things into ASM matcher string pair. How's this used here? String pair. I wonder we should make also like this, straight this without pair. Or we change this here. Well, it goes into a map. Pair. for consistency, how about we also make this a struct? Struct string pair. Pair. Yeah. So pair. Pair. Oops. Okay. Okay, let's get back to runner. So, where is it? What? Here. Good. So let's put yeah. Let's put this here into runner. Here. CPP file pair map. Okay. So we create a new function here. Load CPP file content. Okay. Contents plural. Load CPP file contents. So this will return this. And what do we pass it? I don't know. We pass it string pair. Yeah. String pair CPP file names. Yeah. Okay. And it will return this CPP files. Okay, so So we will have a CPP file pair map, and we put it. Let's put it here for now. CPP files file okay. And we also need string pair CPP file names. And so I think it would be good to separate these. So output comparison results. Yeah, okay, let's do it in here for now. So CPP files map results. So result, what is in there? Function pair. Function pair. Right. Function pair 0 dot it's a pointer. Get source file name. Okay, so CPP file names dot pair 0 equals that and 1 that. Good. And then so CPP files map. Why don't we make it just a singular? just make it CPP file contents. What is in here? Here, this. Yeah. Return this and just give it a std string with CPP file name. Yeah, I think that makes more sense. Okay, and here we so includes fstream. So EF stream. Oh, that's not a thing. Okay, so std EF stream fstream dot open CPP file name. What is the open mode? fstream open well it is a EF stream, so isn't the open mode automatically iOS base in? I don't know. Why do I have to pass it here? I don't understand. Okay, if fstream dot is open, let's see, fstream read line by line. Get line. Placeholder str. What is that? Huh? Ah. Okay, I see. Why get line? Okay, that's simple enough. It's open. Yeah, okay. what does it return? Okay, so maybe we rename this to F. Very short. F. And let's do std string buff get line. What does it return? Huh? std get line. I don't understand the return type here. Like how, like what does this do? Maybe it's checking is good. Let me see. EF stream. Operator. No. Yeah, operator. No. Bool operator. Is good. No, it's not here. I don't understand what this returns. If we don't understand it, then get line. Get line. Stream size. I don't understand how this is supposed to work. Why get line? It returns. It returns an iStream. But let me see. Dot good. Operator bool. Aha. Can we inspect this? No, we can't. So I assume that this operator bool is checking is good or something like this. Okay, let's just assume that this magic works. Yeah. While get line. Buff. And we have this here. Specify content. If I can. File content. Let's make it return a boolean. Return, well, bool success false. Return success. Success equals true. Okay, remove this. Okay. Okay, load content bool. Okay, and then we have this. Okay, while that open content dot lines dot emplace back oof oof. I think this is legal. std move boof, and then it will be empty again, pretty much. Maybe. Content lines and place back std move boof. Yeah. Yeah. Yeah, we cannot really know how long this file is before we get through. So we just emplace back, it's fine. We'll probably over allocate, but yeah, it's okay. Good. Load CPP file content. And so we call this CPP. CPP files. We don't need this. Instead, we do CPP file pair. No, we do CPP file pair map iterator it equals map dot find results dot where do we get the function name? Maybe we should have a some comparison results. Maybe we should have function name here. I know that in our first instruction, there will be the label with a function name. We don't need function name. What am I saying? We need source file name here. Right. Okay, so if it yeah, let's put std string source file 0 source file 1. Let's put them up here. So find that if it equals dot end. Then oops. Then we put it here equals load cpp file contents. Hold on, that's wrong. Okay, CPP. Well, okay, I realize I'm on the wrong track here. The problem is how do we, so we need a pair. We need a pair, but well, the CPP file actually it's fine. We can have the string just be the first. No, because if it's empty, then that doesn't work. Ugh. Okay. Let's do a new class here. Class CPP file storage. CPP file content storage. Okay. And in here, in there, we will have this thing. And we do CPP files map. CPP files map. We will also have CPP SCD string. So last file, last accessed, last file. Last file name, iterator, last file IT. Okay. So we do CPP file pair. Maybe it should not be a pair. CPP, just CPP file contents. Yeah, const. Okay, let's call this content map, and here we put contents. Okay, so find contents. Let's rename this to file content storage, file content map, file content, file pair. I think this here will be a const pointer pair. Okay. File content. So we do files, file content map, iterator, last file IT, files map, last file name. Good. Then file content by name. Well, std const std string name. Okay. That returns file content, and this will, if no, this dot find files map. Let's comment this garbage out. Files map dot find name iterator IT equals that. If IT is not end, then return IT second. This one needs to return a pointer. IT second, return null pointer, and close that. And here open that. Okay, then and then we have also function void or bool load content, and we also pass a name, load content, and there we do here. Let's just copy this whole thing, put it in there. Name, content lines. Ugh. If find name, if IT is not end, then return false, already loaded. If not, is open. Return false, return true, true. And here we do mfiles map dot insert hint IT move reference. Yeah, that's yes. File content, and here std move content. Doesn't work. Ugh. Why not? IT. Where? Pair. Ah, right. SCD map move insert. Huge. Make pair. SCD make pair. In place. Okay, so it looks like we do std make pair move content. Is that right? And name. Okay, that could work. Failed file failed is already loaded. File open fail. Okay, so we have a load content function and we have a find content. Yeah, load content. And load content, it will not duplicate things. Good. Then let's do here file content storage. We put that here. CPP files. Sorry. And we put here CPP files dot load content source file 0 and source file 1. And that doesn't work. Why? Inaccessible, of course. Public. Privates. Okay, there we go. Okay, so this is simple enough. Load contents, good. And then we just pass it. Well, we don't pass it. So this will now go through all the comparison results. We'll check the source files of every function. We'll load the files that are in there, which may be just 1 or 2. And then it's ready. And then here, as it iterates this thing here, the result here, again, the result. So here we can then say, we can remove this. And we have a file pair. File, let's do file content pair. Yeah. And we go to runner. And we put the file content pair. I put here file contents. And we put here source file 0, file contents dot pair 0 equals source file 0, no, cpp files dot load contents, no, find content, file content, source file 0 and source file 1. So one of these will be empty here for our purposes. Yeah, file content source. You can also make this, oh, it needs to be const ref, yeah. Const ref, oops. Let's copy this and put it here. Okay, so this should work. Let's put a breakpoint here. Hopefully that compiles. No, cpp file content. Okay, this function we no longer need. Let's comment this out. Let's remove this. Yeah. Let's move this guy, file content storage. Let's move that. Yeah, let's move that in here for now. And runner this thing. Let's remove this guy and this guy. Runner and this here, yeah. Okay. Okay. And then we can make this a declaration and this as well. Okay. And now we can also optimize this here. Find content. Well, the question is this really worth it to optimize it? Let's go without this here for now. Actually, the more we push in there, I think there's benefits. Yeah, let's test this. So find content, what we can say is here fast path. Here we put last file name equals name, last file iterator equals IT. Yeah, fast pass if last file IT is not .end. Ugh. Last file IT equals IT. Hold on, it's this here returns a auto pair dot std map return insert return. A pair, iterator, and a bool. Auto IT. Iterator. Okay, so it does return. Okay, let's just do it like this then. Okay, so if this is not fastpass, last file name. Okay, so here last file name equals name. So if not end, last file T, we need a constructor storage runner okay, and we need iterator with it here. Iterator equals file map dot end, and then we do here the fast pass if not equal that, and name equals that. Yeah, if that is true, then we return last file IT that, right? Yeah. Okay, so this would be fast pass search. Okay, so the lookup should be relatively optimized for our use case, because we expect that the functions that come one after another, they will typically be in the same referencing the same function, the same file, right? So you have a block of functions, like let's say 50 functions. They all come one after the other, and they all belong to the same file. So it will always enter here and get it fast, right, without searching. Yeah, but then there might be the odd situation where then it references some other file, and then it will skip over here, and then it will find the new, and then it will update the last file iterator and plus file name, which will then be for our next fast pass. Yeah, fast pass, lookup, search map. Here we need to return, and that doesn't work. Return value type does not match the function type. What is the iterator? Does it need to be const? Const ends. Iterator. Const. What's the problem here? Okay. So we dereference the iterator. Ah, it's a pair. Right. Second. There we go. What is the problem here? Oh, because we made it const. Yeah, it's not const. Well, we can still make it const. But we just make these guys mutable, which I guess is fair enough. Let's do that. So at least that prevents modifying this map then. Yeah, okay. Good. The lookup looks good to me. Then let's get back to our function. Let's delete this guy here. And that's okay. Well, it's quite a little bit more complicated than I initially had anticipated. Good. Let's compile this. Okay, that compiles. Great. Okay, let's see if this works. Set source file, yeah. Good. Source file 0 is that, and this should be empty, yeah. Okay, so it's absolute path. Let's see. Load content. Okay, so this is end. Then this will open. Yeah. Okay. Content, yeah. Buff. Yeah. Get line. Buff. Include. That's good. And place back. Include critical section and so on. Okay, that's great. So now we have 39 lines. Let's see how that looks. Bunch of includes, extern, critical sections, win main, blah, blah, blah. Okay, this looks good. Then we insert this guy, which moves it. So this one should now become empty. And it does. Good, it moves away. And now it's in our map. Yeah, this looks Good. And the last IT is that, yeah. And the last file name is that as well for the fast lookup. Okay, and it returns true, and we have it loaded. Okay, this is great. Now the next iteration, let's see. Huh? Oh, there's just one function there. Right, okay. Well, it's simple enough. Okay, and then here we should now get the source file again, the same as here, yeah. This is fast enough. And now we here, basically we should have the fast lookup because this is set and this will match. So this is fast and boom, done. Yeah. And this one is finds this. Here we can also make yeah, let's here we need to say if name empty, not empty, then we do this, otherwise return null. Or you make it let's make it here. Return null pointer. Okay. And then here, actually, we don't need to check this, I think. Instead, we should assert it. Assert. Yeah. Because it's implicit. If this is set, then this should be set as well. Yeah. Okay, let's try this. Good, so it will load the stuff there. And then it will find the contents here, fast path, yeah. And here, this now should return early, and it does. Excellent. Good, and then we can pass this now to this thing here. So here we have exe file name. So I say we pass it here. Append to string file content pair. Let's open this guy here. String pair const file content pair. CPP file contents. Or it's just CPP contents. Yeah. Or maybe CPP maybe it should be file text. File text pair. Or text file pair. file content, text. Let's call it text. So it should be text file. Text file contents. Yeah. Then this is text file content pair. Okay. Then let's get back to ASM printer. CPP. Let's call it CPP texts. CPP texts. Okay. And yeah, I think that's good. Text contents. Okay, runner. Okay. Good. Then let's compile that. Let's rename this to CPP texts. Okay. CPP files, CPP texts. Okay. Okay, this looks pretty solid to me. Yeah. So basically we first have a CPP load step, and then once the loading is done, we will open the file for writing, and everything is in memory at this point, and it will just output to this file, and then we'll close it. So there's no overlapping file IO. It first does the reads sequentially, and then the writes afterwards. And it does not do the loads every time, because eventually a file is already loaded. Let's see if there is ever the case where we have multiples in there. Let's see. So yeah, let's put a breakpoint here. So here we have one. So here we have two. So we have ASCII string.h and main.cpp. Because it's from previous. Right. It's from previous. Result bundle. Result bundle. Because it's loading, it's not a compilant, but it's loading the headers. Result bundle. So if we don't sort by compilant, but it's just by source files, then that would mean it's always just one. Let's see. Still two. Okay, why? Game engine. Okay. 3. Okay, so if we just go by CPPs, it will only ever load one after another. Yeah. So it's only if we had a compile and then it would maybe mix them up. I don't know. Yeah, I wonder if we... Seven, 8, 9, 10, 10, 11. Okay, let's do the following. Here at the end, let's add a new function, void clear. And put that here, void clear. And we do map files dot clear, and last file is the method cend and dot clear. Okay. So now the question is, let's end this. If we do cpp files dot clear, now the question is, can the cpp files conditions I hope it doesn't complain. cpp files dot size is not 0, is bigger than 1. Let's see. Breakpoint cannot be set. Expression has side effects. Okay, well, then let's do it differently. Runner. Remove if cpp files dot here dot empty, no, dot size larger than 1, then let's put a I don't know, let's just clear it. I need some instructions so I can put a breakpoint. So yeah, okay, let's do that. Yeah, so basically, I just want to see if there's a case where if we have grouped, bundled the stuff by source files, if there's ever the case that our file map actually has more than one entry. And it doesn't. Okay, what if we... let's go to main. And we change this to compilant, group by compilant. Then it can be. Yeah, that's what I thought. Okay, so 2. So it can have main CPP ASCII string. And we got an assert. Ah, of course. Let's just clear this. Yeah. Okay, so it can be 2, 2, 2, 2, 2. Okay, just a bunch of times it's 2. Okay, then I think what this means is output comparison results, comparison options, bundle type, result bundles, bundle result bundles. Okay, let's just pass bundle type here. Bundle type. And so that is here. Bundle type. Outputs, comparison, results, bundles. Bundle type. I pass that here, and so we say here if bundle type equals source file, then we can always clear it at the end, right? But if it's a compilant, then we don't clear it. Yeah. This would be, let's put a, Let's put a assert here. Assert cpp files. Storage. Runner. Clear. Void size. No, size t. Size. Clear. Let's put the size up here. It's const. And clear is here. And we put the runner here. And we return this dot size. All right. Okay, so let's go back down here. So assert cpp files dot size equals smaller equal 1. Or it's just a smaller 2. Yeah. Source cpp files for source file bundles cpp file count, or let's say concurrent cpp file count for source file bundles is expected expected to be less than 2. Yeah. Okay, let's remove this guy. Runner, clear. Okay, let's put the private back. Let's run this once. Okay. Let's go back to main. Let's put a breakpoint here. Main.cpp. Source file. Compile. Run this. Okay, now this hits, and it's always expected to be smaller than 0, smaller than 2. Yeah. Okay, this works. This works. Good, and then we pass this on now, and now we can finally actually start printing it with the CPP text present here. Good. Now we have all the ingredients to print this, I think. Yeah. We have all the data. Yeah. Good. All right. Yeah, then I will take a break now. Yeah, that's it for today. And yeah, next video we continue here with this function, and hopefully it won't be too difficult. We touched quite a lot of functions already. It is a big change. Yeah, it's a big change. That's okay. Okay, good. Yeah, I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.